Hi everyone, this is the fourth video for section 6.3 on multiplying and dividing fractions. So like I said at the end of the last video, we're going to start this video by talking a little bit more about the models that we can use for division of fractions. So we're going to do an example now where we talk about 1/2 divided by 1/3. So just like when we've done multiplication all the times before, when we do 1/2 divided by 1/3, all that means is how many groups of size 1/3 are there in 1/2. So in order to represent this using a model, I'm choosing to use this pattern block model. We've talked about this in some of the previous videos where we had a whole was these two hexagons put together. A half is then one of the hexagons, and a third is one of these wedge type shapes. So I'm just going to kind of outline what this shape looks like with all three wedges filled in. So if this is one of our wedges, then we have another wedge, not right there, here, right? We have another wedge here. And then we have our last wedge is just what is left over here. Sorry, cannot draw it straight. Okay, so our last wedge is what's drawn right here. Okay, so this is how that shape is divided into three different wedges. Okay, so we want to know how many groups of size 1/2 are there in 1/3. So we know what 1/2 and 1/3. We've drawn our whole. We've drawn what half of our whole looks like and what a third of our whole looks like. And now we want to see how many wedges can fit in this size 1/2. So if you have physical pattern blocks or if you have the app that we've been using, you can do that. For the purpose of this video, I'm just going to draw it in. So we can see that if we translate this shaded wedge over here to on top of the 1/2, then it looks like this. Right, we can see that one of our wedges will fit in this 1/2 section. Like so. So we can see that one wedge will fit in there completely, but we still have some extra shaded part left over. And so we can see that this shaded piece right here, so this part's left here in our half after we've already put in one group of size 1/3. It's just half of this wedge right here. So we can see that in our 1/2 shaded piece here, we have one whole wedge and half of another wedge. So that tells us that we can, whenever we take 1/2 and divide it by 1/3, we're finding the number of groups of size 1/3 there are in 1/2. Okay, when we do that, we get 1 and 1/2 to represent one part, 1/3 that fits in there completely, and then the half that is also there. So this is just another way of using the pattern block model to represent division of fractions. Okay, so now we're going to transition. Well, we're not going to transition per se, but we're going to look at an algorithm of how to divide fractions using a common denominator, because there's a difference when we divide fractions using a common denominator and fractions that don't have a common denominator. So if we're going to divide fractions using a common denominator, we need to rewrite the fractions. Well, if we want to divide fractions using a common denominator, the first thing you need to do is rewrite the fractions with a common denominator, if that's the strategy that we want to use. And then all we have to do is divide the numerators, divide the denominators, and then simplify. So you can see this is really similar to the multiplication algorithm. So this is really similar really similar to the multiplication algorithm, right? We just divide straight across on in the numerator and the denominator, and then we simplify. So One reason to have students learn this algorithm for dividing fractions is because it brings some continuity between the multiplication division algorithms, that these are just the same. And once you have the common denominator, everything works out really nicely. But that is essential for this algorithm to work. Yeah, and so kind of thinking about this, why we can do it this way. So if we think of the denominator as a unit, then whenever you get a common denominator, it's just converting units to be the same, right? You convert the units to be the same. And then once you have a common unit, they cancel out, right? You don't need to think about them anymore. So you can just ignore the units to do the calculations, right? So if you're trying to think of, I don't have an example off the top of my head, but once you have the same units, you don't have to think about them anymore. You don't have to do any more conversions, because finding the common denominator, we've already done the conversion. And then we just keep division. We just have to consider division in the numerator. So thinking about it in terms of the denominator representing units, this kind of makes sense why we can do this. Okay, let's do an example. So we want to divide 3/4 by 1/2. Okay, so using the common denominator algorithm, we can do 3/4 divided by 1/2. And we rewrite this using a common denominator. So we have a common denominator of 4 here. So then we do 3/4 divided by 2/4. We just divide straight across. So we get 3 divided by 2/4 divided by 4, which is 3/2 over 1, which is just 3/2. Whoops, 3/2, which is 1 and 1/2. And you don't have to do this last step of making it a mixed number, but you can if you want to. So this is using the algorithm, and everything should work fine. But just to make sure that everything works the way we want it to work, we're going to check it using these fraction bars, which is another model that you can use to denote fractions. Fraction bars are more useful when you have physical strips of paper. So we're not going to talk about them too extensively in this videos, just because we're limited by the fact that I have to do all these videos on the screen. So this is going to be the only time we talk about these fraction bars in this section. Okay, but these are fraction bars. And we have a fraction bar. So all of these are the same size. So this long skinny rectangle just represents one. And we can divide it into pieces of size 4 or pieces of size. We can either divide it into 4 pieces or 2 pieces to represent fourths or halves. So when we have our whole and we divide it into 4 pieces, we want to consider 3 of them. So we have 1, 2, 3. We have these 3 pieces, and we want to know how many groups of size 1/2 can fit into 3/4. So in order to do that, we convert this 1/2 fraction bar to being 2/4 of the fraction bar, because we just multiply by 2/2, which is our additive identity of 1. So we convert our fraction bar that is 1/2 into 2/4. And then it's a little bit easier to see how we can fit this in. So we want to fit 2 of these rectangles into the 3/4. So we can see that well. We can put 2 of them here. And then we have 1 left over. So that 1 left over, we have 1/4 left over. Well, that's just half of our 2/4. So we have 1 that fits completely here in the red. And then we have 1 half left over. So we can fit another half. So another one of these. I'll go this way. So another one of these, or half of 1. So another 4th corresponds there, and a 4th is a half of a half. So this is how we can kind of look at it using fraction bars, is converting one fraction bar of half of a whole to instead being 2/4 of a whole is the same thing. Okay. Okay, that's all for this page of the notes. So that's all for this video.